So we will start the event with the first introductory talk that we wanted to have today, so that everyone knows about what are we talking about when we talk about fairness of AI in medical imaging. And for that, we asked one of the organizers and also an invited speaker today, Andrew Keane, to join today. So Andrew is reader in medical image analysis at King's College in biomedical engineering school. So Andrew, the floor is yours. Thanks.
Thank you, Enzo. So I hope you can see my screen now.
Yep, perfect.
Yes.
So yeah, we thought it would be useful just to give a bit of an overview, because this is quite a young field. It's still developing quite fast. Papers are appearing quite rapidly these days. So we thought it would be nice to give a bit of an introduction, overview of some sort of key concepts and terminology, and some of the key papers that have influenced the field, just to sort of set the context for the rest of the workshop. So thinking about fairness and bias in AI, let's start off with first like an intuitive definition of fairness. So we're not even thinking now about AI specifically. So we can talk about fairness as being the absence of any prejudice or favoritism towards an individual or a group, based on their inherent or acquired characteristics. So this is something that I think we can probably all get on board with intuitively. So fairness in AI refers to methods for assessing and or addressing such prejudice or bias. So really what we're talking about here is that if we train an AI model, what most people would do is evaluate its performance on some test set of subjects, and they would just leave it at that. But what we mean by bias in AI is that the performance of that AI model might be different for different subgroups or even individuals of the test set. So in general, those subgroups could be anything, but in general, we're talking about things like demographic groups, like sexes or races or different age groups, for example. And I guess another thing to say is that quite often, the field of fair AI mostly came from computer vision, and in computer vision, they talk about mitigating bias, as if bias is something that can be sort of removed completely from their AI models. I would say in medicine, it's more sensible to talk about addressing that bias, because I think maybe this is something we'll come to later on in the workshop, but it's not always straightforward to understand or to really know exactly how we want to deal with the bias which is there. I think it's a lot more complex in medicine than it is in many other machine learning applications. There's some terminology which is quite commonly used that I'd like to introduce in fair AI. So when we're talking about these different groups, for example, genders or races, then quite often people talk about protected attributes, or another word for that would be the sensitive attribute. So that just means the characteristic for which fairness needs to be ensured. And if you have a group of subjects that have the same value for a protected attribute, then we often call this a protected group. So it might seem intuitive to us what fairness means, but actually, the more you think about it, the more nuanced I think these definitions become. And we can talk about different types of fairness. And so a number of definitions have emerged mostly from the general machine learning literature. So the most obvious one is what we will call demographic parity. So if we're talking about a classification problem here, and then we have a number of protected groups, so for example, males and females, then to ensure demographic parity, we would want to have an equal chance of being classified as positive for your main task for each protected group, which might seem initially a sensible thing to do, but then, and in many computer vision applications, I think it is a sensible thing to do. But thinking about some medical applications, for example, certain diseases, if you're talking about a disease classifier, certain diseases will have higher prevalence in some protected groups than others. So if you ensure demographic parity, you might actually be harming the performance of your classifier. So in those cases, you might want to go for one of the other definitions of fairness. So for example, equalized odds, which looks at equal false positive rates and false negative rates, or the equal opportunity definition of fairness, which only equalizes either one of those two. I'm not going to go into all of these definitions. This is just 3 of the common ones. There are several others as well, but I really just wanted to raise this to make you aware that fairness, although it seems an intuitively obvious thing, when you get down to the specifics and try to define it, you need to be a bit more careful and clear about exactly what you mean by fairness. So thinking about methods to address the bias, assuming that you found some bias in your AI model, then there are a number of techniques. And again, these have mostly come from general machine learning or computer vision literature for addressing bias. Notice I'm not saying here mitigating bias, because I think that's a bit of a simplification, but we're talking about ways here of addressing the bias that we've found. And if we think about the stages involved in training an AI model, generally we would have 3 stages. We would do some preparation of the data, we would do some training of the AI model, and then we would do inference. And we can intervene in each one of those 3 stages to try to ensure that the bias is addressed satisfactorily. And we will call these 3 stages, or the ways of intervening in those 3 stages, pre-processing, in-processing, and post-processing algorithms. So this slide here just summarizes a number of the different techniques that have been proposed. I won't go into all of them in detail, but just to pick one from each column. When we talk about a reweighing approach, you might, for example, modify the weights of different training examples. So if you've got one group, protected group, which is underrepresented, you might want to sort of increase their weighting. In the in-processing algorithms, the metafair classifier, for example, the bottom one of that middle column, this would do like a multitask training where you would train for your main task, but also do a multitask training to try and predict the protected attribute. And the idea of that is that by doing that multitask training, it would sort of learn to sort of come up with a model which is less biased. And finally, you can do it at inference stage, which, so in this case, for example, reject option classification, this will change the outputs of the model afterwards, after the inference has been made, to try to make them more fair, according to whatever definition of fairness you've chosen. But as I say, there are many different possibilities here, and there's some nice review papers out there, and I'll show you a list of papers at the end of this presentation, which you can look at. So thinking about the literature on fair AI, so there's a couple of different tasks that we can identify. So first of all, assessing bias and then addressing bias. And I think it's interesting to look at the numbers of papers which have come out, first of all, from the general machine learning in AI community, and then more specifically in the medical image analysis community. So fair AI has mostly originated from the general machine learning community. And if you look at the literature in that area, then you will find hundreds or even thousands of papers. There are whole workshops devoted to fair AI in general machine learning and computer vision. So it's a very young field. It's only been around, I would say, the last 3 or 4 years, something like that. But already there are many, many papers coming out from the general machine learning community. I think personally that medical imaging is one of the most high impact areas in which bias can have a damaging effect. So thinking about applications, for example, in facial recognition and computer vision, clearly it's very important to have a fair model so that minority groups are not misclassified more often than majority groups. That's very important. But in medicine, if we're talking about choosing diagnoses or choosing treatments, we could literally be talking about a matter of life or death for the patients. So you would think that medical imaging and medicine in general would have a lot of papers on this. But it's actually quite surprising. I found it quite surprising when I first started to look into this field that there's a very small number of papers in medical imaging. I think probably less than about 30 odd in terms of bias assessment. In terms of addressing bias, I think we're down to single figures. So as I say, it's quite surprising that there's been so few papers, but it's also quite exciting that this is a great opportunity for everybody here in this meeting to sort of get on board with this exciting new research area in a very early stage. The reason why I think there are so few papers on addressing bias, and again, this is something I hope we can come back to later, is that it's not always clear to us how we should address the bias in medicine. I think in computer vision problems, it often is quite clear, but in medicine, it's a bit more nuanced and a bit more complex. So what I'd like to do now for the rest of this introductory presentation is just to take you through what I think are some of the key papers in fair AI. And we'll talk about why I think they're important for us to appreciate. So although this workshop is about medical imaging and medicine, the first paper I'd like to talk about is not from medicine at all. It's from computer vision. I like to start off with this because it's had a really big influence on the field. So this was written in 2018, and I think it's already been cited more than 1,000 times. So it's a very influential paper. So this was a paper by Joy Bolamwini and Tim Gebru, who recently gave a keynote presentation at MICI, if you were there. And this was looking at commercial gender classification models from video images. And there was a number of commercial systems that were available at the time, and they basically evaluated the performance of these models based upon different protected groups, and in particular on intersectional protected groups. So intersectional groups refers to, for example, Black women or white men. So looking at multiple protected attributes. And what they found was that these commercial systems were very biased. They performed well on white people and on males, and they performed less well on females and on minority races. And the reason for this was that the data that was used to train these models was mostly from white males. Just as an aside, I think it's interesting to note that both of these authors have gone on to become quite well known since this paper. So Joy Bolamwini has recently had a Netflix documentary made about her and about her work on this particular paper. And she now runs the Algorithmic Justice League. And Timnit Gebru has been famous for other reasons. So she was sacked by Google last year for apparently highlighting lack of fairness in some of Google's own projects. And she's now started up her own distributed AI research institute. So both of these organizations are sort of campaigning for fair AI techniques. So moving on now to medicine. So we're not quite on medical imaging yet. This is ECG analysis. And this is not really a paper about fairness as such, but really the starting point for any analysis of fairness is to show that there is bias there, to actually to do open and transparent reporting. And that's why I think this relatively early paper is a good one to talk about. So this was a paper that looked at training AI models for analyzing ECG traces and sort of to try and predict some sort of clinically useful information. And they looked at the effects of race and ethnicity on these AI models to see whether they were biased. In reality, in this particular case, they didn't actually find any bias, but I thought it was nice that they actually tried to investigate it. And there's one nice quote from the end of the paper here, which is that we recommend reporting of performance amongst diverse ethnic, racial, age, and gender groups for all new AI tools to ensure responsible use of AI in medicine. So I think that's a nice take-home message and something that I think many of us can learn from in terms of publishing our work. The next two, again, they're not really about bias as such, but they're very strongly related to bias. So these are papers from Judy Gajaya and from Aaron Koiner. And both of these papers were trying to demonstrate that there is the potential for bias in AI models. So both of them are trying to predict protected attributes from imaging data. So the one on the left, Judy Gajaya's paper. So this was showing that you could predict subject race from a range of imaging modalities, including chest X-rays, CTs, and breast mammograms. And this is important because bias can occur in AI models mostly down to two factors. Generally, if there's an imbalance in the demographic distribution of the training data, that can lead to bias, but it has to be combined with what I would call a distributional shift. So there has to be some difference in appearance between the images from one protected group and another protected group. And if that distributional shift is there, then it should be possible to train a classifier to identify the protected attribute. So the fact that you can train classifiers to identify protected attributes with quite a high degree of accuracy shows that there is the potential for bias. And that's why I think these two papers were important. So the one on the left showed that deep learning models can be trained to predict the race of the subject from multiple medical imaging data sets. And the one on the right was a similar idea, but they were trying to predict the race not from the images themselves, but from automatic segmentations of vaginal fundus images. This is another paper. This is one of the early papers that was looking at demographic bias. This is a paper from MICI a couple of years ago. So this was a paper that looked at skin lesion diagnosis. And so I thought this one was important because first of all, it highlighted a lack of reporting, a bit like the ECG paper that I just spoke about a couple of slides ago. It highlighted a lack of reporting about demographic bias in the literature, and it argued for how important that is. And it also found some bias in an AI model by protected group, in this case, sex and age, in skin lesion classifier. And there was also a simple bias mitigation scheme demonstrated there as well, which was nice. So one of the main areas in the last couple of years that has kind of been leading the way in terms of bias, AI bias, has been in chest X-rays. So there's a couple of important papers here by Narasabal on the left and by Sayed Kalantari on the right there. And both of these have found biases in AI models for classifying chest X-rays. So in this case, it was gender, age, and race. And these were sort of CNN-based chest X-ray classifiers trained from a number of public data sets. The Larasabal paper on the left had quite a nice approach, I thought, where they sort of systematically varied the level of imbalance and then observed the effect of this on the bias. So the figure on the right there, you can see the horizontal axis is the percentage of females in the training set. So they were looking at gender bias. And then the vertical axis is the performance of a classifier for male subjects. Just looking at the test performance on male subjects. So you can see that as you add more female subjects in, then the performance gets worse for male subjects, and they observe the converse as well. So this was quite a nice approach that has inspired similar studies in other papers as well. Just following on from the chest X-ray work, there's been a couple of other papers from Ben Glocker's group, which I think have been quite interesting. So in particular, the first one has looked at has proposed an analysis framework. So this was a nice paper, I thought, because it argued that there's a distinction between bias being present in the features learned by AI models and the bias actually being used by the AI models in making the decision. And the bottom one there was a response to one of the earlier papers, which had some very nice discussion as well about the influence of these biased features on the classifier. So chest X-rays was, as I say, it's been one of the main areas so far. So there's been a few papers there, and slightly maybe a newer area, which seems to be an emerging area, is in brain imaging. So there's these three papers that I'm aware of that have looked at bias in brain imaging. So the story here is, I would say, is a bit more mixed. So a couple of them has found some potential bias, and one did not find any potential bias. I mean, that sort of apparent contradiction, I think, is due to the fact that the tasks are different in the different papers. So I think I would say that there may be bias in brain imaging tasks, but it is likely to be dependent on, well, first of all, the protected attribute you're looking at, but also the task. So it depends what kind of classifier or what kind of model that you're trying to train. So I would say keep your eye on this area of brain imaging. It seems to be an emerging area and one where there is potential bias, but the story is not completely clear just yet. So far, all of these papers I've been talking about have been classifiers. So they've been taking an image or images as input, and they've been trying to predict some categorical value. For example, does a person have a disease or do they not have a disease? A lot of the work that we do in medical image analysis is around segmentation, which is a basically pixel-wise classification. And so another emerging area just in the last year or so has been looking at bias in AI-based image segmentation models. And this is starting from the paper you can see on the screen there, which was at NICI last year in 2021. And since then, there have been a number of other papers that have followed on from that. This is quite an interesting area, I think, because it's one of the few examples of medical image analysis leading the way ahead of computer vision. So I'm not aware of any work from computer vision Fair AI, which has looked at bias in segmentation. Maybe that's because segmentation is a more important application for us in medical image analysis than it is in computer vision. But it's interesting that in this particular case, medical image analysis seems to be leading the way. I'm not going to say any more about this because we are lucky enough to have one of the leading figures in this particular field speaking to us later on, as Esther Puyol and Tom. So Esther will tell us more about this work later on. A couple of other papers that I would also like to highlight. These are not really experimental papers. They're not sort of doing not analyzing a particular problem. They're not doing new experiments. But I think it's really important that we talk about what we actually mean by fairness and what kind of fairness we want to achieve. So these works here by Melanie and Enzo Ferrante's group at the bottom there. So there was some really nice discussion. I'm not going to try to summarize all the interesting points that were made. I would recommend that you go and have a look at these two papers if you're interested in exactly what we mean by fairness. So these both had really interesting discussion about what types of fairness are achievable or even desirable in a medical context. And I think that's important before we do all the experimental work and come up with methods for addressing or mitigating bias. It's important that we understand what we want to achieve. And hopefully that's one thing that can come out of this workshop. So that's my whistle-stop tour of all of what I think are some of the key papers. I'm sure I've missed some really excellent papers there, and I apologize if I've missed your favorite paper. It would be great to hear from you. If you think we have missed out particular papers, it would be great to try and build up a resource of what are the key papers in the fairness in medical imaging area. But I just want to close by pointing out that this is a rapidly growing field. So I did a quick PubMed search looking for the keywords in the title of fairness or bias, and then either AI, deep learning, or machine learning. And you can see that it's really growing significantly in recent years. But also, it's quite really interesting to note that that particular search only had 122 results. So we're not talking about masses and masses of papers yet. We're at a stage now where you probably can look at every single paper that's been written on medical imaging and fairness. You can't do that in, for example, in segmentation. You spend your whole lifetime reading all the papers that have been written on segmentation. But at this stage, at least, you probably can do that in fairness and AI. And it's great to be here in the early growth stages of this particular field. But as I say, it is growing rapidly, just in the last 2 years or so. So it's a great time to get involved in this field. So this is my further reading. So as I say, I'm sure I've missed lots of papers, and if I have, then please get in touch with us, and we'll try to put together a resource, maybe like a literature review, a reading list for people that are interested in this particular field. So I think I'll stop there, and do we have time for some questions?
Yes, excellent. Thank you, Andy. Thanks and applause from everyone. I have to do this virtually here. Thanks for this excellent overview. And I think it's really setting the scene for the rest of the day. There are a couple of questions coming in. First, I want to throw one question at you from the poll. So do you see the opportunities outweighing the risks for AI in fairness for medical imaging?
So personally, I voted yes to that question in the poll. I think it's really, when I first started to look into this, into the idea of bias and fairness in medicine, I spoke to some doctors and I asked them about bias in medicine, and they said, of course, there's bias in medicine. The whole healthcare system is horribly biased, and many groups are receiving substandard healthcare. So I think we're not starting from a position where everything's wonderful in medicine. We're starting from a position where everything is horribly unfair. And I think AI is, my personal perspective is that AI has got a significant role to play in addressing some of these health inequalities. I think it's not without risks. I think we do need to be aware of some of the challenges and risks as well. But for me, I think opportunities outweighs the risks at the moment.
Excellent. There are some questions coming in on the chat. I would probably ask you to have a look at those. Some are very specific and just need an extra pointer to a paper. So maybe you can take that offline. Let me just check. Yes, so there are already other people answering the question, which is also great. I would also ask people to do share other papers and links, anything that you know about. And Andy has said that he has done a great coverage of some of the works, but obviously people in the audience might know of other works. So there was a question about a specific application in MRI. If anyone knows, do share links and information that you might have. Otherwise, in the interest of time, thank you, Andy, again.